Hello and welcome. In continuation with our series of gravimetric analysis, we have discussed how a precipitate needs to be formed, what are the requirements of a good precipitate, what are the requirements of a wash solution which is to be used, and after the precipitates have been filtered, what kind of process needs to be used for the removal of water molecules which are adhered to the precipitate. And we have discussed there are two types of ways in which the adhered water molecules can be removed depending upon the type of the water molecules which needs to be removed. And those are the methods which are used are heating or the ignition of the precipitate. Heating of the precipitate, which we have discussed, is in case where simply moisture needs to be removed from the precipitate, and ignition of the precipitate needs to be done where the moisture or the water of constitution along with moisture or water of crystallization needs to be removed. So, once we talk about the thermogravimetric analysis of a precipitate, in this case the changes in weight of a precipitate versus temperature are plotted and interpreted. As you can see in the adjoining figure, the temperature which is taken on the x-axis and the weight or change in the weight of the precipitate which is taken on the y-axis. The change required is decided and the ignition temperature is fixed for a particular precipitate. So, therefore, the basic idea of a thermogravimetric analysis or plotting a graph of thermogravimetric analysis is to get an idea that at what temperature the water of constitution will be removed from a particular precipitate, or at what temperature the ignition can be done or the ignition temperature can be fixed for a particular precipitate can be discussed from this analysis. So, once we come to this various steps which we have discussed in details in our previous lectures, the steps in gravimetric analysis, the very first step is the preparation of the solution. That means if we have a particular salt in which we have to determine the amount of the metal ion which is present in that salt, then of course the determination cannot be done in a solid salt. First of all, the solution has to be made of the metal ion and then only the estimation can be carried out. So, first step is the preparation of the solution. This solution can be made simply in water or generally depending upon the ion which is there, various solvents can be used. After the solution has been prepared, the solution needs to be heated and then diluted, and after that the precipitation is carried out, which is the second step, in which the precipitating agent is added to the solution. The precipitating agent which is chosen is according to the ion which has to be precipitated. That is, we first need to know what kind of ion will form what kind of a precipitate. According to that, the precipitating agent needs to be chosen. After the precipitates have been formed, the third step is the digestion of the precipitate. And as we have discussed, digestion of the precipitate can be done either by keeping the precipitates overnight or by simply heating the precipitates in solution on the steam bath. Digestion of a precipitate is done to remove any chances of error due to either co-precipitation or supersaturation, and these are the sources of error which we have already discussed. After the digestion of the precipitates has been carried out, filtration now is the next step, wherein the precipitates are filtered either through a Wattpan 40 filter paper, which is an ashless gravimetric filter paper, or they are filtered out through a filtering medium like a silica glass crucible. After the filtration, allowing the precipitates to remain on the filtering medium, washing of the precipitates is done to remove any kind of adhering impurities. Once the washing has been done, and for washing, as we have discussed, the electrolytes need to be added in the wash solutions to avoid peptidization. After the washing has been done, the precipitates are then dried and ignited. Drying and igniting of the precipitate is done according to the quality of the precipitate, whether it will get decomposed, what kind of water is to be removed, and so on. And after igniting the precipitates are then weighed out, and the precipitates are weighed, they are actually giving us a weight of the precipitate. But what we need actually in gravimetric analysis is the amount or the concentration of the metal ion. So, by a series of calculations from the weight of the precipitate, we can find out the concentration of the particular metal ion in that solution which has been provided to us, or solution, or even a water sample, as in that case may be. Apart from general precipitating agents, certain organic reagents can also behave as precipitating agents, or as we say, can behave as precipitants. There are a number of organic reagents which can be used. For example, DMG, which is also termed as dimethylglyoxime, and oxime, which is also known as 8-hydroxyquinoline. Both these reagents are insoluble in water. Therefore, some other organic solvent is used to prepare a solution of either DMG or oxime, because all the reactions which take place are taking place in solution. Therefore, the precipitating agent should also be in solution form, and DMG or dimethylglyoxime is soluble in alcohol. So, to prepare DMG, alcohol and concentrated sulfuric acid are added, and the DMG solution is prepared in 1% alcohol solution. Nickel ion is commonly precipitated using dimethylglyoxime, and it is precipitated as a nickel DMG complex, which is very common. It is a red precipitate which forms. Lead can also be precipitated as this DMG complex, which is giving a yellow color precipitate. Just like nickel is giving a rose red color precipitate or simply a red color precipitate, lead can also be precipitated, which gives a yellow precipitate, which is the lead DMG complex. Now, in this case, if suppose we have a sample, solution sample in which both nickel and lead are present together, then we have to estimate both nickel ions and lead ions in that solution. And as we have just seen, nickel ions also precipitate as nickel DMG complex, lead ions also precipitate as lead DMG complex. So, if both nickel ions and lead ions are present together as a mixture in a solution, then since nickel forms its DMG complex in alkaline medium and lead forms its DMG complex in acidic medium, so just by changing the pH of the solution, the two ions can be separated. So, this is very simple. If there is a mixture of nickel and lead, a same precipitating agent can be used to separate them also in the solution, because nickel will form nickel DMG in alkaline medium, as you can see on the slide, and lead will form its DMG complex in acidic medium. So, first nickel can be precipitated in a mixture of nickel and lead by taking the medium as an alkaline medium by adding ammonia, so that the medium becomes alkaline. And after nickel ions have precipitated, and once we have checked for complete precipitation, then the medium can be changed by adding excess of mineral acid, so that lead forms its DMG complex and precipitates out in the acidic medium. So, in this way we have got both nickel as a red precipitate and lead as a yellow precipitate by using the same complexing agent or a same precipitating agent in the same solution. Bismuth ions can also be precipitated as its DMG complex even in the presence of nickel ions, palladium ions, silver ions or zinc ions by using dimethylglyoxime along with EDTA and cyanide as masking agents at a pH of 11 to 11.5. So what do we understand by this paragraph is that EDTA forms a very good complex with nickel, lead, silver or zinc. So if bismuth ions are present along with these ions in a particular solution, then all these ions, nickel and lead especially, can form a very good complex with EDTA and can be masked by EDTA. Similarly, cyanide in the form of potassium cyanide can form good complex with silver ions as silver cyanide or zinc ions as zinc cyanide and can mask silver and zinc in a solution. So therefore, what is remaining is bismuth ion in the solution, which is not forming any kind of precipitate with EDTA or cyanide, and therefore it can be precipitated as a DMG complex in the presence of these particular metal ions by the masking technique. And this reaction needs to be carried out at a high pH, that is in the alkaline medium having a pH of 11 to 11.5, highly alkaline medium. DMG is used as its 1% ethanol solution in gravimetric estimation, and along with ethanol, concentrated sulfuric acid in a very small quantity is also added to dissolve DMG, and the remaining volume, for example, if you are preparing a 100 ml solution or 1 liter solution, in that case the remaining volume is made up by water. Now in this case, excess of DMG as an organic precipitant should be avoided for the precipitation of nickel or lead or bismuth. This is because, first of all, DMG might itself precipitate out since it is insoluble in water. So if excess of DMG is added in water, then DMG is an organic precipitant, and if excess quantity is there itself, it will get precipitated out. The second reason why excess of DMG should be avoided is the precipitate might dissolve slightly in excess of alcoholic solution. So if DMG solution is in excess, that means alcohol is also in excess. So if alcohol is in excess, the precipitate might get dissolved in that alcoholic solution. The disodium salt of DMG helps to minimize these sources of error since it is water soluble. So therefore, simply using DMG might result in these kind of errors in gravimetry. To avoid such kind of errors, disodium salt of dimethylglyoxime is used because it is soluble in water, and for that matter sodium salts of all metal ions and generally all organic precipitants are soluble in water. As we have discussed earlier also, in case of EDTA again is an organic compound which is therefore insoluble in water. So a disodium salt of EDTA can be used in cases where complexation is carried out, because again the disodium salt is water soluble. Coming to the next class of organic precipitants which is oxine, and it has the formula C9H6ON. It forms a complex in the form of M, where M is a dipositive ion, MC9H6ON whole twice. When M is a dipositive ion, it forms a 4 coordinate complex with oxine. In case where M is a tripositive ion, it forms a 6 coordinate complex with oxine. Now oxine is a bidentate ligand, therefore a 4 coordinate complex will be requiring 2 moles of C9H6ON, whereas in case of 6 coordinate complex, 3 molecules are attached to the metal, since again as I have mentioned, oxine is a bidentate ligand. So it needs to satisfy coordination number of the metal accordingly. In case where 4 units are attached, 4 molecules of C9H6ON or oxine are attached to the metal, in that case metal is a tetrapositive ion which forms an 8 coordinate complex with the oxine. The complexation with oxine is pH specific for each metal ion, and thus the pH range can be selected to carry out the separation of the anions or metal ions. And this is exactly similar to the case we have discussed in case of TMG, wherein if we have a mixture of ions, metal ions, then according to the pH in which the precipitation can be carried out, pH can be changed, pH range can be selected, and if there is a mixture of ions, then those ions can be separated simply by changing the pH. Now, the 2% solution of oxime in 2 molar acetic acid is suitable for low pH range estimations. That is, in cases where the precipitate which is formed can be formed in an acidic medium or a low pH range, then in that case a 2% solution of oxime can be made in acetic acid. 2% solution of oxime in alcohol, that is ethanol or methanol, is suitable for high pH range estimation. So, for low pH, an acid can be used to prepare the solution of oxime. For high pH range estimations, ethanol can be used to dissolve oxime. If the hydrated oxime complex needs to be weighed, that means once oxime complex has been formed and now it needs to be weighed, then this oxime complex is of course containing water molecules associated with it. Then the precipitate can be heated to 110 to 120 degrees to remove the water molecules which are attached to it, and this will give in case of an hydrated oxime complex, whereas for anhydrous oxime complexes the heating should be carried out to 140 degrees centigrade. Upon heating the precipitate to 140 degrees centigrade, all the water of constitution will also be removed and the oxime complex which will be obtained will be anhydrous. However, for some oxime complexes, heating to a temperature of 140 degrees may result in the decomposition of the precipitate, because ultimately oxime is an organic precipitating agent and oxime and organic reagents are prone to decomposition at high temperatures. Hence, ignition at high temperature is carried out only if the metal needs to be weighed as its oxide. That means, if we consider a particular metal and it is precipitating out using an oxime reagent, then the metal will form its oxime complex, but when it is ignited to a temperature of or heated to a temperature of 140 degrees centigrade, then oxime will decompose. So, for those cases, for example, in case of ferric ions can be used to form oxime complexes and can be precipitated out as their oxime complexes, because ultimately ferric ions need to be weighed as its oxide, that is in terms of ferric oxide. So, what we have discussed till now in this particular chapter or topic of gravimetry is that gravimetric analysis is a method of quantitative analysis to estimate the concentration of a particular metal ion in a solution provided. There are many methods of quantitative estimations, and one of those is gravimetry. Some other methods which are titrimetric analysis, complexometry, acid-base analysis and so on. Gravimetric analysis is a method of estimation of ions by precipitating the ions and calculating the weight of the ion after its precipitation. Gravimetry is also associated with a number of errors which can take place, including co-precipitation, post-precipitation, peptization, supersaturation and many more. All these sources of errors need to be minimized. They cannot be totally removed due to the working conditions, due to everyone's practical hand, but these conditions can be minimized according to the required amount of the precipitate by various methods which we have already discussed. The precipitating agents which need to be used in gravimetric analysis, precipitating agents, or as we say precipitants, which need to be used in gravimetric analysis, should be having specific properties which should not be reacting with the solution, with the metal ion, and should simply form a precipitate which should be of a good quality, can be weighed easily, and can be giving a compound of a definite composition. That compound of a definite composition may be simply the precipitate obtained, or it might be obtained by igniting to remove all kinds of water molecules attached to it, or in terms of moisture being attached to it. And many kinds of precipitating agents which are used, which include inorganic precipitating agents, organic precipitating agents. Care which needs to be taken for using organic precipitating agents is that generally organic precipitants are prone to oxidation, they are prone to decomposition at high temperatures. So, upon using organic precipitants, again number of points have to be kept into mind. In case of nickel forming a complex with DMG, as we have just seen in our previous slides, nickel DMG which is formed is a red color precipitate. This red color precipitate is very fluffy in nature and it is spread out through whole solution. So, upon filtration, sometimes since the precipitate is spread out through the whole solution, therefore co-precipitation might occur, the size of the precipitate might be small. So, to remove those kind of errors, digestion of the precipitate is carried out. Digestion of the precipitate is carried out not only for nickel but for many other precipitates, probably all other precipitates which are formed, and digestion which is an important step in gravimetry to remove or minimize, I should say, co-precipitation. However, digestion increases post-precipitation in some cases, but then post-precipitation is minimum after digestion, since the solution is heated to a very high temperature, and once the precipitation has been carried out, digestion has been carried out, then filtration which is carried out, which precipitates or filters out all the precipitate which is required, and after that the precipitate which is heated can be obtained as in the constant composition as such or upon ignition. And from the precipitates which are obtained, for example, if nickel is precipitated as nickel DMG, then the amount of nickel from nickel DMG, because the weight which has been obtained is of the nickel DMG complex, not simply of nickel. But what we have to calculate is the amount of nickel in a solution, and that can be done by a series of calculations by taking the weight of the precipitate and then finding out the amount of nickel in, for example, in nickel DMG complex or lead DMG complex or barium in a sulfate precipitate, and by a series of calculations we determine how much amount of a particular metal ion is present. And this process of gravimetric analysis, which is carried out in the labs, is important for estimation of metal ions in water, wherein heavy metals are present in water. Then how much concentration of these heavy metals are present can be decided or can be found out by this method, and various other uses of gravimetric analysis which can be used as a quantitative method for the estimation of metal ions in a particular solution, apart from the qualitative analysis, since it is determining the amount of the metal ions in a particular solution, particular given sample. Thank you.